Good day, guys. So today we are going to be talking about MKS SI units with dimension of derived quantities. You all know that we can have three types of quantities. We have the fundamental quantities, derived quantities, and what? Supplementary quantities. We only have 7 fundamental quantities, 2 supplementary quantities. All other quantities in physics, they are what? Derived quantities. And these quantities are actually derived from what? From the multiplication or division of 2 or more fundamental quantities. Now, today we are going to be talking about MKS and what? SI units with their what? Dimension. Whenever you hear MKS, it simply means meter, kilogram, and second as the unit of what? Length, mass, and time. M is meter, that is unit of length. K is kilogram, that is unit of mass. And S is time. Sorry, second. That's the unit of what? Time. Okay, so that's that, guys. So you have to know that this length, mass, and time, they are the first three quantity under what? Fundamental quantity. They are the first three fundamental quantities. So once we've known their MKS unit, we can also know their what? Dimension. And whenever you want to know the dimension of any particular fundamental quantities, we usually represent the dimension of a fundamental quantities by the initial letter in capital form. We're going to say that the initial letter of length is L. That is why its dimension is what? L. The initial letter of mass is M. That is why the dimension of mass is what? M. Why the initial letter of time is T? So that is why dimension for time is also what? T. So this simply means that whenever you are talking about dimension, do not mistake it for what? Unit. The unit of length is meter, but the dimension is L. The unit of mass is kilogram, but the dimension is M. The unit of time is second, but the dimension is what? T. Now let us look at some examples of what? Derived quantities, their units, their fundamental units, and their what? And their dimension. The first one is area. Area is equal to length times breadth. This is the formula for area. So whenever you want to look for the MKS unit of any quantity, you have to know the what? The formula. So area is equal to what? Length times breadth. Then you have to know that the unit for length is meter. The dimension for length is also what? L. But you have to understand something, that length, breadth, height, distance, radius, displacement, all these have the same unit. That is why we can also refer breadth to as what? Length. And that's why the unit for area is what? Meter times meter. And that's equals to what? Meter square. The dimension will be what? L times L. And that's equals to what? L square. So length, breadth, height, distance, displacement, they all have the same units. Okay, the same thing as volume. The formula for volume is length times breadth times height. So since breadth and height has the same unit as length, that is why the unit for volume will also be what? Meter times meter times meter. And that's equals to what? Meter cube. And the dimension will also be what? L times L times L. And that's equals to what? L cube. And let's move on to number 3. That is what? Density. Okay, guys. Number 3. Density. So density is an example of derived quantity. So I told you already that whenever you want to know the unit or dimension of a derived quantity, you firstly have to know the formula. The formula for density is mass over volume. Mass over volume. So now let's talk about the unit of density. Units. So this simply means that you have already known that the unit of mass is what? Kilogram. And the unit of volume is what? Meter cube. Therefore, the unit of density will be kilogram over meter cube. So guys, you have to understand that this particular expression I have here, I can also rewrite it as this: kilogram times 1 over meter cube. Because kilogram times 1 will still give me what? Kilogram. Then you have to know that from the idea of indices, from indices idea, if you have something like 1 over x, it can be written as what? X raised to power minus 1. This division will change to minus. But if it is 1 over x squared, it will be what? X raised to power minus 2. So this division will change to what? Minus. So that is why if I have something like 1 over m cube, I can also write it as kilogram per meter cube. So this is the unit for what? Density. But if I want to talk about its dimension, do not forget, if I want to get the unit or dimension of a derived quantity, I have to know the formula. Since the formula for density is mass over volume, the dimension for mass, don't forget, the dimension for mass is what? Capital M. that is capital M, over the dimension for volume, that is L cube. L cube. Then this can be written as M times 1 over L cube, and it can be equals to what? M L per cube. So that is that about that. So you have to understand this indices idea. Guys, let me go to number 4. That is speed. The formula for speed is distance over time. Over time. And guys, kindly remember that I told you already that the units for length, breadth, height, distance, and displacement, they are the same thing, which is what? Meter. Since they have the same unit, they will also have the same what? Dimension. So that is why the unit for distance will be meter, and the unit for time is what? Second. We can also rewrite it as meter times 1 over s, because meter times 1 is equal to meter over s, and 1 over s will be written as what? Then to be equal to meter per second. Okay, number 5, velocity is equals to displacement over time. Over time. Displacement has the same units as what? As distance. So this will also be equals to meter over s, and that's also equals to what? Meter per second. Therefore, speed and velocity have the same units, which is meter per second, and also same dimension, that is to say LT minus 1. Don't forget that meter is the unit of length, but the dimension for length is L. Second is the unit of time, but the dimension for time is T. That is why the dimension for speed and velocity will also be what? LT per L, or LT raised power minus 1. Do you get that? So you have to know that speed has the formula distance over time, velocity has the formula displacement over time. But speed and velocity, they have the same units, which is meter per second. They will also have the same dimension, which is LT raised power minus 1. Guys, let's move on to acceleration. Guys, for acceleration, you have to know the formula for acceleration to be velocity over time. The formula for acceleration is velocity of time over time. Please, guys, don't make a mistake. The formula for speed is distance over time. The formula for velocity is displacement over time. But the formula for acceleration is what? Velocity over time. So therefore, the units of this acceleration, velocity, that is meter per second, time, that is second. So since we already know that the units of velocity is meter per second and the unit of time is second, then this can be rewritten as meter per second times 1 over s. Do you get that? Don't forget, we have already known that the unit of velocity is what? Meter per second. So that is meter per second times 1 over s. Now don't forget that 1 over s can also be written as what? S raised to power minus 1. So this can be equals to meter per second times s raised to power minus 1. Then this will give us what? Meter per second squared. And if we now want to look for the dimension, that would just be, you know, since we've already know that the unit of acceleration is meter per second square, since meter is the unit of length, the dimension for length will be what? L. So that is L. Since second is the unit of time, the dimension for time will be what? T. So that is T raised to power minus 2. So this simply means that the unit of acceleration is meter per second square, but the dimension for acceleration is LT raised to power minus 2. So guys, let's go to number 7. That is force. Do not forget that the formula for force is what? Mass times acceleration. Mass times acceleration. Mass times acceleration. And remember, let's talk about the units. The unit for mass is kilogram. The unit of acceleration is meter per second square. Meter per second square. So this simply means that the unit of force is what? Kilogram meter per second square. Then if you now want to talk about the dimension, since the unit of force is kilogram meter per second square, this simply shows that kilogram is the unit of mass. The dimension for mass is what? M, capital M. Meter per second square is the unit of acceleration. The unit of meter is, the meter is the unit of length. So this simply means that the dimension for length will be what? L. Second is the unit of time. This simply means that the dimension for time will be what? T. So this simply means that the dimension for force will be what? MLT raised to power minus 2. But guys, note. Don't forget that the SI unit for force is also what? Newton. The SI unit for force is Newton. So since SI unit of force is Newton, this simply means that 1 Newton is equals to 1 kilogram meter per second square. So this simply means that the unit of force can either be Newton or kilogram meter per second square. Do you get that? So if I ask you that Newton is equivalent to what? So Newton is equivalent to kilogram meter per second square. This is the dimension, this is the unit. Now let's move on to work. Guys, you have to know that the formula for work is actually force times distance. The formula for work is force times distance. So if you want to talk about the unit of work, number one, the first unit of work is actually, you know, the unit for force can be Newton and distance is meter. So number one is can be Newton meter. Do you get that? It can be what? Newton meter. This is the first unit of work. Now, the second unit of work is joules. You know, the unit of force is Newton. The SI unit of work is Newton. So for force is Newton. So as the SI unit of work is also what? Joules. Now, the third one will now be, you know that the MKS unit of force is kilogram meter per second square. So this simply means this will be kilogram meter per second square times meter. So this can be equals to kilogram meter square per second square. So the first unit of work can be Newton meter. That is force times distance. Newton times distance. Newton meter. The second unit can be joules. And the third unit is what? Kilogram meter square per second square. So therefore, this simply means that is to say Newton meter equals joules equals kilogram meter square per second square. Please note this very well, guys. Kilogram meter per second square is the unit of force, but kilogram meter square per second square is the unit of what? Work. Now, number 9, energy. The formula for energy is T force times distance. Therefore, work and energy as same units and dimension. Now, you know, I've already said that the formula for work is force times distance. The formula for energy is also what? Force times distance. Since they have the same formula, this simply means that work and energy will have the same unit. And how many units do we have for work? We can basically have 3. The first one is Newton meter. The second one is joules. The third one is kilogram meter square per second square. So this simply means that all these 3 units for work will also be the same unit for what? Energy. So work and energy has the same unit. So therefore, they will also have the same dimension. So if you want to get the dimension for work and energy, you're going to get it here. You know, this is kilogram meter square per second square. Kilogram is the unit of mass. The dimension for mass is what? M, capital M. Meter is the unit of length. The dimension for length is what? Capital L. So this will be L squared. Second is the unit of time. The dimension for time is what? Capital T. So it will be what? T raised to power minus 2. So this simply means that the dimension for work and energy is ml square t raised to power minus 2. But the dimension for force is ml t raised to power minus 2. Now, guys, we are talking about that power. The formula for power is work over time. The formula for power is work over time. So let's talk about the units of power. Units. Number one, the unit of power is watts. That is the SI unit of power. Now, number two, the unit of power, you know the unit of work is joule, time is second. So the second unit for power can be joule per second. Number three, the unit of work can also be Newton meter. And the unit of time is what? Second. So therefore, number three units can be Newton meter per second. And finally, the units of power. Now, don't forget that the units, the MKS unit of work is kilogram meter square per second square over S. You know, power is work over time. The MKS unit of work, as we did in number 8, is kilogram meter square per second square. So all over S. So this will just be written as kilogram meter square per second square times 1 over S. You know, if this 1 over S, it can be written as what? S raised to power minus 1. So this can be written as S raised to power minus 1, right? Then the fourth unit of power can be kilogram meter square per second cube, because we have S raised to power minus 2 here, we have S raised to power minus 1 here. So combine the two together, it will be what? S raised to power minus 3. So these are the 3 units of power that we can have. Now, let's talk about the dimension. Dimension of power. Now, since the MKS unit of power is kilogram meter square per second cube, then kilogram is the unit of mass. The dimension will be capital M. Meter is the unit of length. The dimension will be L square. Second is the unit of time. Then this will be what? T raised to power minus 3. So this simply means that the dimension for power is what? ML square T raised to power minus 3. Let's look at number 10. This is pressure. Pressure. Now, the formula for pressure is force over area. So if you want to talk about the first unit, this will be force is Newton. Number one, the unit of force is Newton. Area is meter square. Then this will be Newton per meter square. The first unit of pressure is Newton per meter square. Now, number two, since the MKS unit of force is kilogram meter per second square, the unit of area is meter square. Then this can be written as kilogram meter per second square over meter times meter. Meter will cancel meter. It will remain 1 meter up down here. This will be kilogram per second square over meter. Then if this meter goes up, it returns to kilogram per meter per second square. So you have to know that pressure is force over area. The MKS unit of force is kilogram meter per second square. Area is meter square. This meter square can be written as meter times meter. So 1 meter up, we cancel 1 meter down. It will remain 1 meter down. This will now turn to kilograms per second square over meter. If this meter goes up, it will be what? Kilogram per meter per second square. So the second unit of pressure is what? Kilogram per meter per second square. Then let's talk about the dimension. The dimension. Now, listen. Since the unit of pressure is kilogram per meter per second square, kilogram is the unit of of mass. The dimension for mass is M. So that will be M. Meter is the unit of length. The dimension for length is L per L. Second is the unit of time. The dimension for time is what? T per T square. So this means that the dimension for pressure is what? ML raised to power minus 1, T raised to power minus 2. Now, number 11. Let's talk about elastic moduli. Oh, wait. Let's talk about stress. The formula for stress is also force over area. Therefore, stress has same units and dimension. as pressure. So this simply means that stress and pressure, they have the same unit and what? Dimension. Now, number 12, let's talk about elastic moduli. Okay, before we talk about elastic moduli, let's talk about strain. The formula for strain is extension over length. Now, the formula for strain is extension over length, but the unit of extension is meter, the unit of length is also meter. So this simply means that meter will cancel meter. That is meter over meter. So this simply means that strain has no units. It has no dimension. But stress has the same units and dimension as pressure. But strain has no unit or no dimension. Guys, let's look at elastic moduli. Guy, you have to know that the formula for elastic moduli is stress over strain. Then guys, if they ask you that what is elastic moduli, now we can have three types of elastic moduli. The first one is Young modulus. The second one is bulk modulus. And the third one is what? We have the Young modulus, we have the bulk modulus, and the what? Shear modulus. So this simply means that whether you are talking about Young modulus or bulk modulus or shear modulus, they will have the same unit as what? Elastic moduli. So this simply means that elastic moduli or modulus of elasticity elastic moduli can also be referred to as modulus of elasticity, can be Young modulus, shear modulus, or bulk modulus. So the elastic moduli, it can also be referred to as modulus of elasticity. It can either be Young modulus or shear modulus or what? Bulk modulus. Therefore, elastic moduli has same unit and dimension as pressure. You know that the general formula for elastic moduli is stress over strain. Either it is Young modulus or shear modulus or bulk modulus. Since stress has the same unit as pressure, but strain has no unit, this simply means that the unit of elastic moduli will still be the same as what? Pressure. So this simply means that pressure, stress, elastic moduli, Young modulus, shear modulus, bulk modulus, all these 7 parameters, they have the same unit and what? Dimension. The units can be Newton per meter square or kilogram per meter per second square. Why? The dimension is what? M L raised to minus 1, T raised power minus 2. Now, let's look at number 14. Velocity gradient. So listen attentively to this aspect. Whenever you hear something gradient, maybe velocity gradient, pressure gradient, temperature gradient, whenever you hear something gradient, it simply means that thing over length. So the formula for velocity gradient will be velocity over length. So guys, if I ask you that, what is the formula for pressure gradient? That will be what? Pressure over length. So if you now want to talk about the unit of velocity gradient, unit. Now, since we have velocity, the unit for velocity is meter per second. The unit for length is what? Meter. This will be equals what? Per second. Also, the dimension would equals to what? You know, the unit for velocity is per second, so the dimension will also be what? Per t. Guys, notes. Okay, before I come back there, let's talk about number 15. Energy density. Now, whenever you hear something density also, it simply means that thing over length. So the formula for energy density will be what? Whenever you hear something density, that simply means that thing over volume. So whenever you hear energy density, it will be what? Energy over volume. Do you get that? And if you also hear mass density, it will be what? Mass over volume. Guys, let me do something. Let me change this question to mass density. Therefore, you guys, you are going to try energy density by yourself. So do not forget that if you are talking about mass density, it will be mass over volume. If you are talking about energy density, it will be what? Energy over volume. So no matter what you are talking about, it will be what? That thing over volume. So for mass density, the formula will be what? Mass over volume. Now, let's talk about the units. This is mass. The unit is kilogram over volume, meter cube. And this will be equal to what? Kilogram per meter cube. So the unit of mass density is what? Kilogram per meter cube. Because mass density is mass over volume, unit of mass is kilogram, volume is what? Meter cube. So that will be kilogram per meter cube. The dimension would also equals to, you know, kilogram is the unit of mass, the dimension is m. Meter is the unit of length, the dimension is what? L h to the minus 3. So this is the dimension. So guys, we are also going to talk about the number 16. But guys, before I talk about number 16, I want to give you two assignments. The first assignment is that if the unit of velocity gradient is per second and the dimension is per t, then velocity gradient will have the same unit as what? Read on that and drop your answer in the comment section. Now, another assignment I want to give you is that go and try the unit for energy density. Once you try the unit for energy density, then tell me that energy density will have the same unit and dimension as what? Firstly, try the unit for energy density, then determine what other quantity will have the same unit and dimension as what? Energy density. Let's move on to number 16. So guys, impulse. Formula for impulse is force times time. So since the unit for force is Newton, unit of time is second. So the first unit of impulse can be Newton second. Now, since the MKS unit of Newton is kilogram meter per second square, and the unit of second is t second, then this second multiplied by s to the minus 2 will give us what? S to the minus 1. So that is why the unit of impulse can be what? Kilogram meter per second square. So the dimension will not be ml t raised power minus 1. Now, momentum. The formula for momentum is mass times velocity. Unit of mass is kilogram, velocity is meter per second. So this simply means that the unit of momentum will also be what? Kilogram meter per second. And this simply shows that impulse and momentum will have the same unit and what? Dimension. So thank you guys for watching. We are going to continue with dimensional analysis in our next tutorial video. So guys, I want to implore you to solve more questions. You can do the question, look for the dimension, you look for the units, MKS units, and dimension for potential difference, electromotive force, Planck's constant, Boltzmann constant. So thank you guys. Don't forget to like, comment, share. Thank you very much.